Hello, my name is Charlotte. Today I will be presenting the earthquake-resistant tower my group and I made in the York Engineering Junior Design Competition. During the competition, my group and I were faced with the challenge of creating a tower that could withstand stimulated earthquakes with and without a load. The challenge involved considering constrictions we were limited to, a budget, and a goal to have the most stable tower using the most cost-efficient amount of materials. Along with the base problem, we are constrained to an 8 by 8 centimeter base and a height constriction of 30 centimeters. We are given a budget of $1,000 figurative dollars we could use to buy extra materials. However, buying extra materials would lead to judges removing points from our final score. This problem is important for future civil engineers such as myself to think about while learning. This is because earthquakes can happen at any time in earthquake-prone areas. To avoid great tragedy, making buildings that will not collapse under the strain of an earthquake is very important. It reduces the effect of an earthquake on the environment and on the economy. It is important that buildings made even in areas usually not prone to earthquakes are able to resist earthquakes, or else unforeseen tragedy can happen. An example of such is the 2023 earthquake that occurred in Turkey and Syria, which caused a tragedy with 55,000 people killed. The earthquake left Turkey with $85 billion in damage, most of which needed to be put towards repairing homes. The devastation the people of Turkey and Syria went through made it ever so clear how important it is to make buildings that can resist the forces of earthquakes and prevent more tragedies from happening. My group and I began this project by counting how many resources we were given to start. We also read the rulebook thoroughly so that we could understand our constraints. By understanding what we could use, we felt more prepared to tackle this important problem. Our resources included popsicle sticks, a hot glue gun, a cardboard base, a ruler, a felt sheet, a hot glue gun sticks, and a pair of scissors. As we have been learning in our engineering courses, understanding and analyzing your problem is the most important step to a solution. It was only after analyzing our resources that we started our research on how we could maximize our materials. We asked the following 3 questions while trying to consider our materials. What shapes should we use for the structure? How can we brace the building for earthquakes? And how can we maximize our materials? To find the best shape to use for the tower, my group and I looked at many different buildings and bridges to see which shape would be the strongest so that the tower stays stable. We looked for the strongest and most used shapes in other buildings that we could recreate with popsicle sticks. We found many tall buildings such as the Eiffel Tower use triangles in their structure. From our research, we found that triangles are very strong shapes due to their sides being rigid. To brace the building for earthquakes, we looked into adding cross bracing, which can be seen in many structures and is used to support the building's load. This helps in the competition for when they add a load to the building, as the cross bracing will help our building to support the load better while under the stress of the stimulated earthquake. To maximize our materials, we did a few calculations to see how we can use all of our popsicle sticks in our tower in a useful and meaningful way. We used these calculations to decide between a triangular base or a square base. We decided on making the base of our building triangular and adding cross bracing. In order to meet the height requirement, we decided on a 3-level tower. However, due to material constraints, instead of doing cross bracing at the top, we decided to make a prism-like shape. Once we had our plan and design ready for our tower, we worked on putting everything together as a team. By having one person glue everything together and the rest of us hold everything in place, we were able to work on and finish the project quickly. We worked on the go to solve any problems that occur. We faced a few problems while building the tower that we had not considered beforehand. One instance of this was when we realized that stacking the second floor of our tower on top of the rounded edges of the popsicle sticks would make it unstable. Our solution to this problem was to cut flat edges so that the second floor of our tower could be glued on stable. Along with this, we also realized after completing most of the tower that we had forgotten to add a place for the load to hang off of on our tower. To fix this, we added a glue stick to the top of our tower in the middle so that it could hold the weight as it is more malleable than the popsicle sticks. To finish off our project, we used the extra pieces of popsicle sticks from cutting flat edges to add extra cross bracing as well as support any edges that were not stable. Finally, this is our final product. The tower met the height and size requirements and passed through all stages of the earthquake test without and with a load. This is a testament to its structural integrity and the research and effort put into it. Thank you.